stay talking the whole time. Uh, Hello, friends. It's 10 o'clock or thereabouts in Redmond, so time for API review. Well, even in English, I don't say on Tuesday. Fun times. Yeah. On the one hand, I have like a full screen worth of issues. On the other hand, it's apparently a European holiday, and a lot of these issues are backed by European prisoners who said they can't be here, so we might have a short day. We'll see. All right. First up, provide an async entry point helper to enable platforms that need an async function, an async return from main. This is runtime 121046. Mr. Robinson.
Okay, so this is Mark blocking. We literally are in the middle of shutdowning 10. How can this be blocking for 11? The idea here is there's a lot of moving parts to this potentially. One of them being this is an API. As you can see, it's under compiler services that Roslyn would need to consume and emit. And because of that, we'd like to get it in early as possible so that the machinery can flow through all these things and Roslyn can do what it needs to do. So the gist of this problem is, for those that do or do not know, when you mark your main as async, if you have an async main, whether it's a void or an int, what Roslyn does is it creates a synchronous main under the hood. And it literally just calls your main and then acquires the awaiter and says get result. So it's kind of just a bunch of magic, and it really doesn't do, it's not really async. It is a blocking call. It's just a bunch of syntactic sugar that actually makes it work. And so what that means is the entry point that Roslyn is generating for an async main is actually synchronous. If you look at the IL itself, there's going to be an async, there's going to be the entry point, and it is a synchronous entry point. This doesn't really work for WASM. And more broadly, it doesn't work for any platform that would expect, that has a, let's say, outer message loop that needs to run. Because if main is just synchronous, it's never going to go back to the outer environment. So for WASM or for running inside the browser, the environment will call our main, and then it will just sit there and block for everything to happen and then return when main is all done. But the problem with that is all of the utilities that are needed by the enclosing system, the JavaScript engine, are never going to run because they're just sitting there in the JavaScript message queue waiting to be executed for whatever main returns. And so what we really need to do is we need main to return when it is in those environments in an async fashion, like to actually operate in that way so that the message queue for the JavaScript environment can continue to process things like IO and cryptography and various other services that it's providing to .NET. And so in order to do this, we're creating this basically implementation detail that for all platforms other than WASM or browser, however we define that, it would operate the exact same way that Roslyn currently does. It would literally just, the implementation of this execute async entry point would take that task, and if you scroll down a little bit, you can see the main returns and main returns int. This literally would just take the task, call get awaiter, called, I think, get result or result, whatever the thing is. That's the current code gen that Roslyn performs. And that will be the implementation for everybody, at least right now, except for WASM or browser when we build it for a browser. But when we build it for browser, what we're going to do is there's going to be a whole callback system that is implemented in there so that it kind of returns in a way that integrates with the enclosing message loop in JavaScript. And so this really allows us to avoid what some people have done, which is That Roslyn generated main is kind of mangled. It's mangled in a way that we can kind of figure out, but that was being encoded, and it currently is encoded in the mono runtime. That is how it finds what the name of the entry point is. And that was kind of shenanigans. I did not like that. And Jan suggested, well, we could go down this route of providing a new API, creating our own implementation that operates the way we expect it to. And it actually simplifies Roslyn's experience. They just have to call this one API and it will just work always. They don't have to figure out and what they want, what they have to do for these generated mains. They just have to call this API. And that's it. Originally, this was called await main. There was some pushback on that. Someone thought that was a bit confusing, which I don't disagree. And execute async entry point was suggested, and I think that's actually clear what's going on. So this is what we came up with.
So for the WASM case, wouldn't these methods themselves need to be promise-based, or are they gonna do shenanigans and
Shenanigans.
okay, because
We could.
they still need to return. So like, if you haven't yet returned from what you called main, you don't have an int to return from the int version. So what's the WASM going to have returned from this function?
So that is how that particular case. So yes, what that's doing is the implementation of this is calling the JavaScript loop in the way that it needs to call it. That's an implementation detail of this. Of that, that's a built-in, I guess, relationship between how this is working and that platform.
Okay, but so the idea is task goes in, synchronous context comes out, but the synchronous or task goes in, the method appears synchronous, and on non-synchronous runtimes like WASM, this function does the job of making that just work.
Yes.
And
Yeah,
in WASM, you probably don't want the return code from main, so you're probably fine.
Yes.
Okay.
Yeah, you completely ignore that. That's not used in this case.
How does it make it work? I apologize if you said it and I missed it, but I mean, I'm assuming it's running some kind of message loop. Is it using this as a signal to some kind of cogen to say replace the whole void main, or is it actually implementing that execute async entry point in whatever message pumping loop manner it can muster?
I think the execute async entry point on WASM is just going to store the task that kind of runs the program somewhere, and then this method returns, and it returns all the way to kind of the JavaScript that originally called the WASM, and then the kind of the message loop is run there. So
that's what I'm not understanding. So then it's because then the Roslyn generated open bracket main close bracket method, it's gonna somehow replace that, or is it's just implementing execute async entry point as a no-op effectively, like you're saying it stores it and then returns and allows it to unwind all the way? Is that what you mean?
Yeah.
I see.
Does that solve a problem? Like, does WASM require that you use async main?
The Blazor app model more or less requires you to use async main, I believe.
Okay.
Oh, as opposed to just using main itself?
Like, if someone wrote their own version of this wrapper, if they just wrote main calling do stuff async dot get awaiter dot get result, are they gonna hang in WASM, block the message pump?
Yes.
Yes.
So the answer for WASM is just use async main.
Yeah, I mean, you don't have to do that, but the problem, if you don't do that, you can't perform any what we would call syscalls. Because the syscalls are pushed onto the JavaScript message queue,
right,
and that they are executed when this thing returns. in an async fashion.
If someone wanted to write their own main, would we say it was supported to have them do some upfront work and then call execute async entry point themselves and maybe do some work after it? Or like what, or are we saying this is only for use by the compiler, never use these yourselves?
Correct. These are not to be used by anybody else. I guess you could, but I don't know why you would.
You could imagine that it's kind of along the same lines of why would you write in WinForms application.run, or why wouldn't you write application.run? And the answer is some people have specialized scenarios where they need to customize their own inner message loop to do things like integrate with async or other scenarios. So, you know, we're providing our own WASM and async main, but what if there's things that people need to do, like set up synchronization contexts before the first async main happens? So is it supported that they could write their own main wrapper that does set up a synchronization context or customize the task scheduler and then call return execute async entry point?
Sure, people can always look at what happens underneath and, take advantage of that, but I don't think we would document this, We say this is just, API to use by the infrastructure, that's used by the infrastructure to make stuff work.
Is this async helpers class the same one that we're putting all the runtime async APIs on?
I found this API is used in a bunch of other spots. I think so. It already existed. That's why, yeah, I mean, this thing already existed. I don't know if this is where we're putting all, like async
Yes.
too.
Yes, it is where we are
Okay.
putting the async v2 things too. It was just, convenient place to attach it to.
It seems to be a bunch of awaiters, which I think was async too.
Is that type marked currently requires preview experimental? No, it's not. Okay.
And it's got marked as editor browser whenever.
And
Right.
and it's not exposed through the system runtime package. At least the catalog crawler doesn't see it at all.
Yeah, that was confusing.
But if it's not
I think that
if it's not in the reference assembly, I don't know that Roslyn can call it.
it will be in a reference assembly. It's just, I think, point in time problem that
Okay.
color is getting confused or something.
Okay, that was more if this was intentionally not in the reference assembly, you might want to pick a different type. So.
So for the int returning one, what's the plan for the browser if you can't block for the implementation for execute async entry point? Like, are you just going to return a fake int, or can you actually block? Or yeah.
No, we cannot block. We cannot block. They would just ignore that on the call.
So it's going to return 0 because there's no way you could have asked it.
Yeah, I see.
Can it not be wrapped in its own promise that ends up returning the int when it's actually done?
Sorry, say that again, Tanner.
Can it not be wrapped in its own promise that returns the int when it's actually done?
I think
Oh, right.
the problem
Then we have
is
to
that they want, like, this is the line of code Roslyn's supposed to generate. So it doesn't matter. Like, if this says it returns a task, then this has to say .getAwait.getResult. And now we're kind of back to where we were.
Yeah, I mean,
which
if you
is the
wanted to
point
go-
of the execute, because the compiler can make it intrinsic and then just do the actual thing and presumably create a promise under the scene that hooks into the message loop
Well, no, the
execute,
compiler
and then when
the compiler writes this, and then
right,
Aaron takes over and implements this.
right.
And from the Roslin's perspective, it is just creating that is the signature it is creating, and that is what the entry point will be. I don't know if it's specified in the spec. I don't know if it is actually in the spec that this is required, but it seems that entry point from a .NET perspective has to appear to be a synchronous method. So marking entry point as task of int, which I think is what you're saying, Tanner, isn't something that we can do.
No, what I was saying is that it won't. What I was saying is that it won't actually block because internally you're taking this construct and you're using the method to the compiler magic to actually make it execute asynchronously. But presumably the thing that's actually calling that actually needs to consume the result from main, if it does at all, would eventually block until it's completed if you use the JavaScript equivalent of awaiting a promise.
But we're not using that because the entry point for this is core CLR's execute assembly or something along these lines. And so that is also a synchronous call as well. And so, yeah, I think what you're getting at is, yeah, we could change that and call that through C++ in a very specific fashion. But then we have to bubble up this promise concept throughout managed, then to C++, then into JavaScript, all the way up through the static host. Like, it seems like that's a lot more work than what is necessary in this case. I think we could, to be clear, but that's a lot more machinery than just ignore the end.
I missed it. If we're squirreling away the task and then execute async entry point is returning, and it's returning all the way up through execute assembly, what's joining with that task? There's some sort of continuation hooked up to the task that will still be invoked even after execute assembly has returned?
Yes, like the basically kind of the WASM runtime machinery will basically or infrastructure take care of that and kind of run the WASM message loop.
Okay.
Like an alternative that was discussed was okay, can we just relax the ECMA specs so that main or the assembly entry point
Could return a task.
can return task, it will be certainly possible, but it's like significantly breaking. So there's a ton of code out there that assumes that main can return int or void. So you would need to chase down all that code, and update it. Now you can also allow task of int or task. So, and at that point, when you look at the kind of cost of pushing this breaking change just for WASM, then we can just say, okay, the hack that the WASM runtime does today and where it reverse engineers the Roslyn generated code is probably okay.
Is it possible for a WASM construction to grab an assembly and grab its entry point and invoke it? Do assemblies still exist at that point? Does enough stuff exist that it could do reflection?
Yeah, you can certainly do it, and it's like if the main is async, it will try throw an exception that hey, you cannot do synchronous waits on WASM.
Right. Well, I guess my question is, if we switch to this and you have an int main and an assembly that you reflect invoke from WASM, is it going to get the 0 immediately, or is that going to just somehow work that it basically suspends the caller, runs the inner main, and then resumes to the caller? Or is that actually going to leak out this early 0.
Well, it depends on the implementation of the execute async entry point. What does it do when you kind of invoke it multiple times, for example? But there's like no way to make this like to run the WASM message loop like mid stack. The only way to run the WASM message loop that pumps the messages asynchronously is at the top level, right?
Right. I guess so. It's if the reflect invoke of an entry point of another assembly can be made to just work with this construct, and we're hiding the fact that there's a promise somewhere, then this all seems fine to me. If it's not going to be capable of hiding that, then I think we need to think about it. But we could just, if that's not supported on WASM, we don't care. But that's part of where I was going with it.
Yeah, it's not supported on WASM today. Like you cannot do that.
So given the fact that no one is ever supposed to see this or touch this, it'll be editor browser will never. My care factor is pretty low. If we think this is the right answer, then fine. The naming is a little strange, and again, I don't really care because no one's going to ever call this. But nothing here is actually being executed, so execute is a strange prefix. Maybe handle or something would be a better name. But again, meh.
Process.
Or the original name await. I know it kind of is like somewhat confusing, but
Yeah, the original suggestion was await main.
or await entry point.
Oh, wait entry
Well,
point.
it's not really a waiting though.
Yeah, especially in WASM.
I mean, if people are interested, and I can share this as well. Like, I can share the. There is a PR with an example of what this will look like.
Yeah. Chat suggests replacing the word with or the verb with run. I don't know that super changes it.
I like run better than execute.
So that link will shows an example of how this will be implemented. If people are interested in it.
I heard someone suggest handle. I know that's super generic, but it seems fine.
That's why I
Because,
like it, because it's generic and it's kind of meaningless and it's very ambiguous.
right, because to your point, like it's already started running by the time you give it a task, right? Like to store away or whatever it's going to do block on, depending on the environment.
We've already probably
My-
spent more time on it than it's worth.
My only other note was that I definitely understand this and its purpose for the entry point and everything else, but it feels like, particularly for WASM and other languages, including things like Swift Interrupt, all these languages have their own version of promises or tasks or asynchronous code type things. And we have the ability to host .NET from those languages. WASM is effectively hosting .NET in its own way here, and that's what this is providing. It's providing the way to make that integration. And so it almost feels like longer term, we want more APIs that allow exposing the .NET async concepts to other languages and helpers to allow wrapping other languages async concepts in .NET. That way you can actually, if you're running a Swift host and you've got .NET running from it, you can properly integrate .NET async calls into Swift. Or if you're calling Swift async from .NET, you can do the inverse. And the same thing is happening here with WASM for JavaScript and other languages in general. So it feels like longer term, we might want something additional and more complex here to allow the integration of promises across languages.
Yeah, I don't know that we have bad integration of task/promise. It's that we have a restriction on what main's allowed to look like. Like if they're calling a function, that may or like I would hope that works, and if it doesn't work, then yeah, we could do that. But I feel like this is actually just, as Jan said, the ECMA spec says main shall be int or void, and this is working around that. All right. Execute, run, or handle are the top 3 verbs suggested. I think Jan said he's in favor of run. Anybody else want to have an opinion?
I think a handler sounds good too to me.
Yeah.
Actually, any of them. Yeah.
I like run or handle. I've got a slight preference towards run because we have task.run, and that works kind of in the similar way as this, which is it doesn't actually await it. It kicks it off and something holds on to it, and as long as it gets joined, then it will actually finish at some point and prevent the return.
The notable difference being that task.run takes a func and not a task is an argument.
Steve, you PM'd tasks. Pick a verb.
Handle.
All right. Steve says it's different than run. All right. Async helpers handle async entry point. I did do some quick checking, and we do have more capital P entry point than lowercase p entry point, so casing seems good. Oh, should we rename the parameter? Should we name the parameter main or just call it task or T? Does anyone care?
It's fine. Main or main task.
Or just task, like the parameter name main made sense when it was called, await main or then.
All right. Anybody want me to hit undo on that? Sold. All right. Thank you, gentlemen. All right. We have a guidelines gap. So popping back a couple weeks to adding the system text rune overloads through string APIs, etc. Tarek, can you describe the issue before I page it back in?
Yeah, I'm not that familiar with F#, but what happened is in F# you can call any API not strongly typed. I mean, like, the type you are passing is kind of ambiguous. But I mean, like, so F# pick up the overload according to the number of parameters for this overload and just execute it. So right now, if any user writing code like that, I mean, like not passing a strong typed parameter for inside the overload, and right now we adding more overloads that are taking the same exact number of parameters that existed with the other overload today. So F# got confused and said and produced like some error telling like, it's ambiguous for the F# to resolve which overload should call. And the fix from the user point of view is just like, make the call strong typed. I mean, like telling like I'm passing this type. So this would resolve the issue. So resolving the issue is easy, but the point here is like every time we are going to add overloads that have the same number of parameters as existing overloads. I mean, I think this is potentially is source breaking for F#. Yeah. So the question is should we restrict ourselves? I mean, like, you know, instead of adding overloads, we making it like extension methods? Or should we say like our guidelines is no, I mean, we should add overloads because like this is the things that by design, I mean, it makes sense. And we are okay to be like source breaking for F sharp at that time.
I think. Oh, sorry. Go ahead.
When you say source breaking for F sharp, can you describe more about how a user sees this and what they need to do in order to get past it?
Yeah, so they will get like some error while compiling or doing it, and the error will say like it's ambiguous call for this overload or something like this. I don't remember the exact error message, but this is what they will get. And for them, I mean, to fix that, they just need to go and make the parameters that they are passing is strongly typed. I mean, like, you know, if they are passing like string, so they say like this is string, I mean, and this will work fine at that time.
Yeah, I'm trying to find the thread where all the breaks were being described on. I actually thought it was linked from here, but it doesn't
Yeah,
seem to be.
they have that change. I mean, the fix for the F sharp compiler. Maybe I can try to find it and show it.
Yeah, the gist, you know, we have the breaking change guidelines. You know, we know when overloads break C# users. So in particular, you know, it's just pretend we already had the, you know, char write and string comparison type, and we'd added rune previously, and now we're like, oh, we missed the comparison type for rune. If that would be the second ever to arity equals method, then F# would go from weakly typed calling is okay to strongly typed calling is required. The question is, do we care always, or do we care because it's string, or do we not care? In general, .NET is a strongly typed universe. F# is a weakly typed language. There will be conflict. We just need to decide where the line is for this change.
I think saying that we can never add an overload that changes the type of an existing overload is too constricting.
Have we talked to? Go ahead. Sorry.
No, I was just finished. I mean, we've done that plenty of times in the past. The ecosystem in general does that. It's not just about core types. I think saying that that's no longer allowed in .NET is we can't go that route.
I was just going to ask, have we talked to the F# team to see if they have a recommendation for how they normally want F# to handle this, or if they have some kind of attribute that works like overload resolution priority? I don't believe they do on the latter, but I know a few times we've hit conflicts, and there's been a couple where they've been like, yeah, we've got no way to handle that, and another couple where they've gone, this is just normal for F# users are expected to handle it when that happens. And so it'd be interesting to know if this is something that's, you know, actually concerning, or if it's something where there's a, you know, we found a break and it's just something that, you know, users should be fixing on their own and avoiding the ambiguities in those cases.
So the issue actually is raised when we saw when our changes flow to and proc the F# compiler. So the compiler guys, I mean, at least one of them is one who raised that, and he was trying just to get this fixed. So he suggested just to do it like change that. I mean, use extension methods instead of overload and so on. But I mean, like, you know, he didn't say like there's there is other ways. I mean, I believe that other than that, just like if we need to fix it the other way, I mean, in F sharp, so we will go and fix the source there, make it strong type as they did. So they already was on the chat. I'm trying to find the issues that they commented on that. Yeah.
The fix that they made to the compiler, does this fix it for everyone or just the compiler code base?
No, just the compiler. I mean, so
I see.
people have the same cases. I mean, they run into the same issue, and yeah, I think Jeremy already got it.
Credit
Yeah,
goes to Jan.
this is how they fix it. Yeah.
Yeah, so because we had gone from only having one arity 2 ends with to now having 2 arity ends with, it said you need to tell me what value is. So they had the loosely typed, I don't know, function here, and they had to strongly type it. And so, yes, I think I 100% agree saying we can never add the second same arity overload. Or sorry, that we won't add a second. A thing with the same arity as something else in a subsequent version, if we didn't do it in the first version. I think we can't go that far. The question is, are we sensitive because it's string?
I think we need to know real numbers to like say, like, just because it's string doesn't mean that everybody calls these methods on string. I really like Tanner's suggestion of the overload resolution priority. Like we have that in C# now, right? Is that what I understood, Tanner?
Yeah, we have it in C#. I don't believe we have it in F#. And looking at the F# fix here, this looks like just the standard way you handle it when inference breaks down in F#. And there's plenty of cases where inference will break down in F#.
Do we know if it would be a big lift to ask them to add that feature? Because then we would have that tool in our toolkit whenever there's this ambiguity to say, hey, occasionally we intentionally add an overload and we want the new one to be picked, but most of the time we'll opt for compatibility and say, like, give the people the behavior that they used to have.
The other note also is, I think we already, I mean, before even adding this new overload, we already have this case. So inside the string, I believe. So I mean, like, you know, we already in this situation, but this is first time I see anybody complaining about that. So because, like, you know, this is in the F# code itself. I mean, so we got the break because of that, and this is just test code. Yeah.
Was it an actual complaint or was it just raising awareness of the break?
Yeah, it's just a break because, like, our changes flow to theirs. I mean, and it started breaking this.
Like this one, there before we did this change, there was only one 2-parameter string.starts with. We only had starts with string comma string comparison. There were 2 versions of starts with that only take 1 parameter, but there was only one that took 2. And so they got broken here because now that there were 2, it couldn't figure out what the type of value had to have been. It couldn't flow the type information backwards. Overload resolution priority, if they supported it, if they said the types are ambiguous, so downplay one of them, hey look, the type is no longer ambiguous. I just don't know if it would be as straightforward for them. I guess it must be straightforward for them because they said if it was an extension method, it would be lower priority and wouldn't have bound.
Well,
So
and you can see that they already had to disambiguate for index of on line 108.
Yeah.
That one wasn't changed because we already had the conflict, and so they already had to handle it. And so that's why I raised the point of, like, was this an actual complaint or was it raising awareness? And it sounds like it was raising awareness, which means that it's not necessarily a bad thing. It's more just like, hey, be aware that F# users may be impacted because you added that. And that's kind of like anytime we add a new overload to an API that's not just slapping on a new parameter,
I mean,
could end up hitting such a scenario.
unless this is a warning as error problem, like this was a build break.
Right.
Oh yeah, ambiguous.
So
If you don't know what the compiler doesn't know what to bind to, it has to.
Right.
halt.
so
But that's the same thing that happens with, it's the equivalent of using var and auto everywhere, and including in public signatures. And so if you don't want type inference in public signatures, you kind of have to be explicit in F# about it.
Yeah.
It's
Also,
kind of one of those things where some libraries choose to use inference because it's convenient. And that's generally great for applications and stuff. But if you have a library, then that risks causing, breaks to your public API surface over time. And so that's what FSI files are for, and other considerations to avoid those breaks. So you can, use inference on one side, but declare what the signature is on the other, or to be explicit and specify the type everywhere so that it can't break over time. It's kind of one of those, I chose to be in a situation where I could be broken by this out
Yeah.
of convenience in many cases.
yeah, I mean the question that I'd raised, and I would like to say that I'm happy with myself for the first thing I asked was, would overload resolution priority fix this? So we all came to the same answer. But my question to them was like, how canonical is this code? Is the way they had it in the before the way everyone would write this, or is this the lazy way to write this, or what? And they said for F# it's pretty canonical. But again, so I'm 100% fine personally with us saying .NET we consider to be a strongly typed system. If something won't break a C# caller, we don't call it a break. And F#, you have the option of always being type explicit, and if you don't feel like writing them down, then every now and then you're going to get a break. If that's our position, we talk about all of the languages being semi sort of co-equal, and I think this is one of the places that the semi might just kick in.
We have these situations in C# too. It's just that this change in particular, I mean, it changes where it's a binary compatible change, but it happens to be source breaking due to an ambiguity, or remember the params thing I think that was the one where it completely compatible change, but we had to pull it just because of ambiguity or type collisions. So it's like, we're going to run into these things. I don't think we want to constrain ourselves. To me, we have to fall back to the pragmatic of like, yeah, we have to be allowed to do it. Let's document it, give people the best chance to self-solve, and then find out if there's a problem with people self-solving, then we go and find ways to make it easier, either through documentation, analyzers, or language features if we have to go there. But yeah, we're so early. Let's just try it.
yeah, the other thing I want to add here is like, this changes in .NET 11, I mean early, so I think we will have enough time during the next release, to watch out about if we are getting what is the volume of any complaints about that, which is like, it can give us also some indication about like, should we do something or should we be okay?
Let's make sure that we do all the notification early for this, that we don't let the breaking change notice sit around, and make sure that we give people the best chance as possible to self-solve. That way, if any of the noise that we get, we won't discount, right? We won't say, oh, that's just because they didn't have the docs yet. We'll say, oh yeah, there's signal here. Let's pay attention.
All right, so It sounds like our collective thinking is we do not take F# arity based type inference into account for breaking changes across versions. As in, we know it will break F# colors, and we're okay with that.
We still want to document it, right? And it wouldn't prevent us from taking the change. There's not an absolute answer. It falls back to the pragmatic one. So, you know, if we do this and then we learn from usage, like hundreds of people saying, "Hey, I can't figure this out," then we would reevaluate. But we're not taking any universal. We don't make this type of change. So we allow ourselves to make it and we document.
Yeah, I think you made a good point about having similar changes for C# and with F# in particular. I think it'd be almost impossible to avoid potential source breaks when adding new overloads. These just happen to be like pretty common methods, so the impact's higher.
Yeah, I mean, we can certainly try, but obviously the people who regularly attend this meeting, none of us thought of this change as being breaking, so none of us would have put the flag breaking. We can certainly try to remember that adding an overload with the same arity, we want a F# color warning, but I feel like either we always care or we just say this is the problem with using F# with weakly typed calls. Deal with it. We can certainly be explicit on string because we broke the compiler. But
it's not a weakly typed call here. That's the issue. Notably, it's declaring a weakly typed signature that then makes a call where there's the ambiguity. So like if you just have x dot starts with and you pass in a string literal, or you pass in anything where value can be inferred to be string, which is many scenarios, it won't break. The issue here specifically, they declared a signature starts with ordinal that took value, and that had to be inferred, and there's not enough context from that alone to infer which starts with call you want.
Right.
So it's not all calls, it's a subset of them.
Sure, but the only thing that we control is we added a second starts with that took two parameters. In this case, there would be a filtering down where the second parameter was a string comparison. But so that would mean if we want to be proactive at warning F# callers about weak call context compile breaks, that means that every time we add the first overload with the same parameter arity as another overload, we would have to make a breaking change notice, and I don't think we'll be good at that.
Right. That would, for example, be every single read-only span of character overload we added over the past 10 years.
Yeah.
I think that's at the point of it is impossible to keep track of, because that's the every change is a breaking change to someone type scenario.
Yeah, if anything, it's like, do we even need a notice? Like F# developers are used to having to deal with these ambiguities. Like it's pretty obvious what's going on. I don't think whoever did this had much trouble like figuring out what the fix was. Like I don't write much F#. I think I could have fixed this without a breaking change notice.
Yeah. The only reason to add the breaking change notice is to improve the SEO, the ability for the user to self-solve. So if we think that it's part of the language that they know how to self-solve this sort of thing, like we don't put out breaking change notices when we have a name conflict, even if we know that we'll have a name conflict, because C# developers are used to resolving those with using statements. So here, if it's natural for them to do it, then we might not need to document. But I don't have that intuition for F#.
Yeah, I mean, certainly one aspect that we would be able to measure it is, do issues get opened where people are like, I don't know what to do with this, but
Yeah, like it's pretty common, like Tanner was saying, to have to explicitly specify the types in your member signatures. Like F sharp, you know, writers like it when they don't have to. It's less code, but yeah, it's pretty common. And they'll know, like, because there's ambiguities all the time. Like, when you initialize, when you have overloads with the same arity to begin with.
yeah. I mean, I assume params isn't a good friend to the weakly called whatever this is, function, extension, potato. All right, so sounds like basically our feeling is, dear F sharp users, we're sorry we broke you, but we're not changing what we feel is a breaking call. We're not going to proactively change comms. Again, because I don't think we'll be good at it. So just making sure that we feel that what we did is right for .NET, and while there's a little bit of suffering for some F sharp callers, we don't want to change how we did it. But we do recommend that the F sharp team do something regarding overload resolution priority, and we would certainly have been willing to put low ORP on the rune overloads. Is that fair?
Sounds good.
Yeah. Barring some other substantial feedback.
And if we got such an attribute later, for like low priority and overload resolution or whatever this attribute means, that would be non-breaking. Like if we wanted to add it to Rune in .NET 12 or something, like the Rune overloads.
Yeah.
Is that true? Yeah.
Yeah, it's theoretically potentially source impacting to user defined types with custom conversions. Because if a user had a type that could, convert one way, then it can potentially impact things. If it can convert to both types, then it's an ambiguity today, and it would solve that ambiguity even in C#. But that's like edge case scenarios of.
Yeah. All right. Does anybody have anything else they want to share, or it sounds like we've thought about it and our answer is no change? Okay. Well, yeah, so chat has asked, is there a more general problem than just like arity based confusion of where some weak type confusion can come in from F sharp that we should need to know about? I answered in chat of, I don't know enough about F sharp, otherwise maybe we would have even thought about this previously, and the F sharp guys didn't raise it. So if you know of a problem in F sharp and you think the APIs that we add in these meetings don't take that problem into account, feel free to raise it. Though, like this one, we may decide to do nothing about it, but intentionally instead of ignorantly. All right, and since there's not an issue here, it won't show up in notes, but we'll all know we talked about it today. Yeah. I'm going to annoy myself by changing this twice during the meeting. Let's see what happens.
Do we have any documentation inside the design guidelines about that? I mean, specifically for F#?
Nope. I mean, the closest we have is make sure that your API works in multiple languages. But
Okay.
these APIs do work from F#. They just they break one kind of calling style from F#. All right. I couldn't remember what was next, so I haven't pre-opened the tab.
The GUID one. Add event source GUID constructors for non-reflection creation, I think.
Yep. All right. What he said. .NET runtime 28290. Jan.
And so event source needs to register event source, at the end, like in the implementations of event source, it needs a name and it needs a GUID that's computed from the name. Historically, we have steered away from exposing just the direct constructor that takes the GUID and the name, and instead, told people, hey, we don't trust that you get the GUID right for the name, by manually kind of typing it in. But that was from the days where we didn't have source generators. Now we have source generators, so we can build a source generator that just computes the GUID from the name reliably without users actually typing it in. So this API is proposal to expose the constructor that takes the GUID, so that the source generators can take advantage of it. We do have that source generator today built internally. It's only used for Corlib because of the API is not public. But once this API is in the public surface, we expect that source generator to be enabled more broadly. So.
Should we make a check? Should we have an assert or some sort of check for the GUIDs match?
Well, we might in debug builds, but in retail builds, if we added that check, it would
Sure.
Sure, yeah. Defeat the purpose of having this in the first place.
So at least we don't make the mistake.
Yeah.
Are both constructors needed?
It's just for parity. There is basically there are these there are exact same two constructors that don't take the GUID. So this is just adding the same.
Okay.
Are you suggesting just keeping the longer one?
Well,
and
if this is system diagnostics tracing event source, because the namespace is missing. Event source has 1, 2, 3, 4, 5, 6, 7 public constructors currently. So this is overloading 2 of them.
I don't think it has any. It doesn't only have. What type are you looking at?
So I see 7 non-private constructors here.
Oh, but those are protected, right? Not public.
So that one's public.
Oh.
Public. Public. Yeah.
I just think.
Hey, a Boolean one. That one's protected.
Oh, that's protected. Okay, that's fine.
Okay, so I guess we don't.
I see 2 public and the rest are protected,
Okay.
at least in the docs.
Yeah, I guess the APIs of .NET doesn't make a visual distinction between public and protected. So all I saw was we're overloading 2 of the 7, and once it wasn't all of them, it's do we need both of them? if there are two publics and we're making there be two protecteds to work alongside them, then sure.
I realize we're getting off track, but what does someone even do with a public constructor? Like, don't you always need to derive from event source for it to be useful?
Well, based on the second constructor, there's a 50-50 chance.
Okay,
Really, no laughs. Come
I
on.
giggled.
Yeah, I think there might be some, kind of weird scenarios where you can just construct event source without actually deriving from it. But yeah, it's like the mainstream use cases you have to derive.
I think this seems fine. My only question would be on order of parameters, and maybe name. Sometimes event source settings seems to be called settings, and sometimes it's called config. And then there's one of the existing constructors is the same as the latter one, except without the event source GUID. I guess I'm just wondering about putting it first rather than sort of always having the name be first. But they're not going to conflict. It's not like they're both strings. They're not going to cause ambiguity errors or anything, so it probably doesn't matter.
Yeah, and it looks like these are currently internal constructors, and it's just that this is one of those. I just want to take the word internal and change it to protected.
Sure.
I'm just like,
Yeah,
I see this exact signature in the source file, so.
yeah, so switching the order of the first two arguments, it will be certainly fine. Yeah.
But I don't know that it really matters. This is such a in all of runtime we have probably 10 event sources or something. 20. It's not a big use case.
Yeah, I think it's my, when you are looking, let's say, at the source generated code, you would see the name first. It just makes more. I think the name being first makes it more kind of visually pleasing. In case
especially
you ever...
if it's spelled out as in that API usage, with the GUID taking up the whole line.
Yeah, of the clicking through source.net, the public constructors I only ever see being called from base. Is the type abstract? No, it is not.
It's split into two files. There's like this tracing logging event source with all the public constructors.
There's a lot of legacy to how the event source is structured. It had also been, I think some of that comes from the fact that it had been both in core lib and then also exposed in a separate package. And so things were split with tons of if defs.
All right, so are we wanting to move it to the end? So we want to just overload the...
I don't think you can move it to the end unless you're going to default it.
Yeah, we'd have to undefault the traits.
I was suggesting just swapping the order of name and GUID, just sticking GUID between name and settings.
Okay. That is not where I thought I was typing. Okay. Yeah, I guess I had the catalog up. So none of them take a GUID, so no matter where we put it, it's not going to break. And what's the long one called? Event source settings. All right, so in the public API taking event source settings, it seems to be called config. Oh, aside from the one that it is called settings. Yeah. We're good at naming things.
I'm just looking at the other parameters. It's so strange to me that this is just that wonderful naming we deal with, that the default parameter, the default constructor for event source doesn't use event source settings.default.
It makes up its own.
Yeah, it uses 4 instead of 0.
Ooh. That means somebody didn't want to name something with a negative.
This was just me chasing the idea of, well, what if we just, didn't expose the first one and only exposed the second one? But then you're forcing someone to guess the right value for event source settings, and the top one is not going to use event source settings.default.
Right. And we don't want to say event source settings equal 4.
Right.
All right. So the string parameter does seem to generally be called event source name. The settings one is either settings or config. Settings is, I think, a better name than config. And the GUID is exposed back through a property just named GUID, but the name is exposed back through a property just named name. So prepending event source onto GUID seems consistent with the design of this class.
Design is a strong.
I'm curious,
Sorry.
it's separate from the API. Like, the GUID is only part of what's accessed via reflection. Like, there's all that gunk to generate the manifest via reflection. We've had an issue open for years to do that via a source generator, and we kind of have the beginnings of one internally. There was a PR that got opened and then closed maybe twice. Do we have plans to actually go and address this end to end, or is this just sort of a piecemeal thing?
I think this is more like piecemeal. The reason why this showed up on the radar, because we have been investigating startup regression between .NET 9 and .NET 10, and we found a number of inefficiencies, and this was one of them. So we said, we should just get this fixed so that it's just stop showing up.
Mhm.
And the manifest generation doesn't actually show up if you just start up. It only, I think, shows up when somebody starts listening to the event source.
Right.
That's also a common scenario, but I'm just explaining why that part didn't show up.
Yeah, I mean, I totally get that we can do it incremental. It just, I don't know. The other one, bug space. I assume as part of doing this work, we'll ensure that all of our event sources and not just the ones in CoreLib utilize this.
Yeah.
Ship it.
Okay, I was gonna ask, are you asking should we be decorating the other things with a don't call attribute, or adding an analyzer, or are you just asking for performance and consistency?
I mean, I was kind of going down the route of the analyzer. Like, do we want to add an analyzer? Or I don't think we want to obsolete the ones. Vance was always big on kind of keeping the simple case simple and only caring about the reflection if you had to. So I don't think I want to obsolete it, but maybe an opt-in analyzer to say, hey, like, you consider calling this other one instead. But it would be even better if we just did the source generator and then no one would have to worry about it.
I was about to say, if we're going to go through the effort of doing anything, I think we should do the source generator. Like, telling people they have to write this like annoying longer bit of code without the source generator to get a slight improvement in startup perf seems, just do the source generator at that point.
Yeah, generator seems like goodness. The concern with obsoleting the other thing is it would make net standard sources annoying. Because you'd have if you just built net standard, you'd not see the new ones, and if you built split compile, then you'd have well, I've already made this constructor public, so I'm gonna keep calling or keep having it. But all right.
Yeah, I expect we will probably need to make the analyzer to come to get to be part of the source generator, and because of in order to utilize the source generator, people might want to delete the constructor that they already have also. So,
I'm just curious, do we think we can do the source generator keyed purely off of deriving from event source, or do we think we're going to need some separate opt-in mechanism? Like if you're deriving from event source and you don't add the relevant constructor, we'll add it for you, that sort of thing.
I would hope that we can either do that, or there is already attribute you can stick on event source to explicitly say what the name should be.
Right.
So, and that attribute can also include the GUID, by the way.
Right. So we don't need it. So we're hoping we don't need a separate one that's like, oh, and by the way, also use the source generator to implement this.
Yeah.
Yeah, great. I like
No,
that.
I don't think we can actually verify that it will work in practice, but like I would hope that we can avoid adding yet another attribute that everybody has to use to get the good stuff.
Yeah, practice schmactice. We'll just make it work.
Yeah, for the most part, me just clicking around, all of the types that are deriving event source are sealed with only a default constructor. So there's not a lot of cascading going on. It's just an implementation call site. Like this is pretty representative of what they look like.
And in order to utilize the source generator, this line will need to be deleted, right?
I mean, they'd still need to specify the name somewhere, and that they want to be in the ETW manifest event format.
Yeah, the name is actually specified on the event source attribute also. So it's like the way this should look once the source generator is in place. The event source name, the name in the attribute can be just the name that's there, so we don't need the constant for it anymore. And the default constructor will be auto-generated.
This attribute doesn't contain all the information of the long constructor, though. So they can't, unless this is 4 and is now the default value, in which case it magically works. But
or maybe
they can't be passing the traits.
Yeah, maybe this case is outlier.
Because all the networking ones look like they specify event source setting, because I see it all right there. But anyway, so you may end up wanting to rev the attribute to go add those extra pieces of information in it.
Maybe, yeah, you need to. Yeah, once we get to the details of the source generator, we can.
Yep. But we can certainly start with this for now. So, any other comments? All right. Thank you, Jan.
Thank you, Evan.
All right. The last two that I had on the agenda are Eric Sarpalis, who apparently is also out. But we'll see. Do we want to talk about adding a join on link, returning tuples, or do we want to wait until we have Eric? Or,
I don't think we're in any rush.
IDIC.
I'd like to hear what the argument for it is. I think it's just a maintainability simplicity one, but I'd like to have someone defend it, just because anytime we add something to link, it's one more thing.
Yeah.
And it's likely to be slightly controversial because of the tuple return. We had such a long discussion on zip and whether that was right for it.
We did, and in the end we added it, and if the answer is this is exactly the same as zip, then it'd be like, all right, we can hold our nose. I do think we made zip name them, though, so this would need
I
to
think so.
name them. But okay, we can wait until we have a presenter. I see, yeah, that it's Shai and Idek, and neither of them are here with us today. I didn't invite Shai because I didn't look here. I only looked here. No, wherever it was. Here. All right. So I guess that means we have 38 minutes of free for all, or we just call it early. Going once. Twice. All right. I believe that means we are adjourned.
Thank you all.
All right. So, yep. Thanks everyone for joining online and having questions about F# that I couldn't answer. And we'll see you next week. Same .NET time, same .NET channel. There's a possibility that we'll be having a meeting on Thursday to try and make up for Europe being out today, but no promises. Whenever we see you next, we'll see you next. Until then, take care, because I started in English. When do we do daylight saving time? I don't know. I get all my answers from the time and date website. It says something. I don't know. When do we change? When does Seattle change? November 2nd. So next week. No, yeah, this Sunday. So next week will be earlier, I think, because I can do math. All right, there we go. There's my ramble. Gone on too long. Take care, and sorry for the Europeans who missed the timing because of summertime ending over there.